This is a multiple-choice question testing your understanding of hyperparameter tuning in ExtraTreesClassifier, a machine learning model. I will need to carefully consider each option. This sets the stage. I'm being asked to identify which statements accurately describe how changing different settings, hyperparameters, in ExtraTreesClassifier affects its performance. This simply indicates the start of the multiple-choice questions. It's a helpful visual cue to separate the question from the answer options. This labels the section containing answer options A, B, C, and D, providing another visual separation. This statement says that adding more trees to the ExtraTreesClassifier always results in better accuracy. I need to consider if this is always true or only true under certain conditions. This claims that reducing the tree depth can reduce overfitting. I will examine whether decreasing the maximum depth of each tree within the model helps to prevent the model from being too complex and fitting the training data too well, potentially resulting in poor performance on new data. This statement describes how changing the min_samples_split parameter affects tree complexity. I'll need to determine if that's correct, and how increasing this value affects the resulting model's complexity. This statement suggests that an ExtraTreesClassifier is always better than a single decision tree at avoiding overfitting. I need to determine whether this is true even if I set the hyperparameters poorly. This is a multiple-choice question testing your understanding of hyperparameter tuning in ExtraTreesClassifier, a machine learning model. I will need to carefully consider each option. This simply indicates the start of the multiple-choice questions. It's a helpful visual cue to separate the question from the answer options. This labels the section containing answer options A, B, C, and D, providing another visual separation. This sets the stage. I'm being asked to identify which statements accurately describe how changing different settings, hyperparameters, in ExtraTreesClassifier affects its performance. This statement says that adding more trees to the ExtraTreesClassifier always results in better accuracy. I need to consider if this is always true or only true under certain conditions. This claims that reducing the tree depth can reduce overfitting. I will examine whether decreasing the maximum depth of each tree within the model helps to prevent the model from being too complex and fitting the training data too well, potentially resulting in poor performance on new data. This statement describes how changing the min_samples_split parameter affects tree complexity. I'll need to determine if that's correct, and how increasing this value affects the resulting model's complexity. This statement suggests that an ExtraTreesClassifier is always better than a single decision tree at avoiding overfitting. I need to determine whether this is true even if I set the hyperparameters poorly. This section introduces the core topic: how to tune the settings, hyperparameters, of an ExtraTreesClassifier model in Sklearn. We'll examine how changing these settings affects its performance. This is a multiple-choice question testing your understanding of how hyperparameters impact ExtraTreesClassifier. You'll choose the true statements about tuning this model. This is the core question. It's testing your knowledge of the model and its settings. It requires you to determine which statements correctly describe how changing the hyperparameters influences the model's behavior. I'm focusing on the parameter max_depth. Reducing it makes the decision trees shallower, which helps to prevent overfitting. A shallower tree is less complex and therefore less likely to memorize the training data, leading to better generalization on new, unseen data. Now, let's look at min_samples_split. This setting determines the minimum number of data points needed to create a split in a decision tree. Increasing this value forces the tree to create fewer branches, resulting in a simpler model that's less likely to overfit the training data. I want to address the parameter n_estimators. While generally increasing the number of trees, estimators, often improves accuracy, it's not a guarantee. There is a point of diminishing returns. Adding too many trees might only lead to small gains in accuracy but significantly increase training time. Finally, ExtraTreesClassifier, being an ensemble method using multiple trees, is typically less prone to overfitting than a single decision tree. However, this isn't a given. Poorly chosen hyperparameters can still cause overfitting even in an ensemble. I'm focusing on how we can adjust the settings, hyperparameters, of the ExtraTreesClassifier model to improve its performance. We'll explore how changing these settings impacts the model's accuracy and tendency to overfit. This is key for building great machine learning models. Let's dive in. This is a multiple-choice question about ExtraTreesClassifier hyperparameters. I need to carefully consider each option and select all the correct statements. This tests my understanding of the algorithm and its settings. ExtraTreesClassifier is a machine learning model that uses many decision trees. The extra refers to extremely randomized. It's an ensemble method, meaning it combines multiple trees to improve prediction accuracy and reduce overfitting. I need to understand how its hyperparameters influence these characteristics. I think that increasing the number of trees, n_estimators, generally improves the accuracy. However, there's a limit. Adding too many trees might not significantly increase accuracy and could lead to unnecessarily long training times. So, it doesn't always improve accuracy. Reducing max_depth makes decision trees shallower, less complex, and less prone to overfitting. Overfitting means the model performs great on the training data but poorly on new, unseen data. Shorter trees are more generalized. min_samples_split parameter sets the minimum number of data points required before a node in a decision tree can split into further branches. Increasing this value results in simpler, less complex trees, reducing overfitting. This is because it prevents the tree from growing overly detailed. While ExtraTreesClassifier generally reduces overfitting compared to a single decision tree because of its ensemble nature, that's not always true. Poor hyperparameter choices can still lead to overfitting even with multiple trees. I'm focusing on how we can adjust the settings, or hyperparameters, of an ExtraTreesClassifier model to get the best performance. Think of hyperparameters as the knobs and dials you twist to fine-tune a machine. We'll explore what each adjustment does. I'm presenting you with a multiple-choice question to test your understanding. We'll work through each option to determine if it's true or false, focusing specifically on how adjusting ExtraTreesClassifier's settings affects accuracy. We're using Sklearn's ExtraTreesClassifier, a type of machine learning model, to solve a binary classification problem, meaning we're trying to sort data into one of two categories. I want to make sure you understand how to adjust the settings of this type of model to achieve better results. Let's talk about max_depth. It controls how deep each individual decision tree in the ExtraTreesClassifier can grow. A smaller max_depth creates shallower, simpler trees. This can really help to prevent overfitting. Overfitting happens when the model gets too good at predicting the training data and struggles with new, unseen data. Think of it like memorizing the answers to a test instead of actually learning the concepts. We want a model that generalizes well. The min_samples_split parameter determines how many data points need to be present before a branch in a tree is allowed to split. A larger number means fewer splits, and that results in a simpler tree, reducing the risk of overfitting. Imagine it like this. You need a certain number of students to justify creating two separate study groups. While ExtraTreesClassifiers, by their ensemble nature, using many trees instead of one, tend to be more resistant to overfitting than single decision trees, this isn't guaranteed. Poorly chosen hyperparameters can still lead to overfitting, even in an ensemble method. n_estimators refers to the number of trees in our ExtraTreesClassifier. While increasing this usually does boost accuracy, there are diminishing returns. After a certain point, adding more trees won't significantly improve results, and it'll just make training slower. It's not a guaranteed improvement. This section focuses on understanding how to adjust the settings, hyperparameters, of an ExtraTreesClassifier model to improve its performance. We'll explore several key hyperparameters and how they affect the model's ability to learn from data and make accurate predictions. Think of hyperparameters as tuning knobs for your model. I'll explain how to prevent the model from being too focused on the training data and instead learn broader patterns for better predictions. Lowering the max_depth parameter simplifies the decision trees, making them less prone to overfitting. It's like pruning a tree to make it more manageable and robust. I'll explain what's happening inside the tree building process. The min_samples_split parameter determines how many data points are needed to create a new branch in the tree. A higher value creates simpler trees, reducing complexity and the risk of overfitting. It's like saying, hey, tree, don't split unless you have enough evidence. I'll discuss the effect of increasing the number of trees in your ensemble model. While generally improving accuracy, there's a point of diminishing returns. Adding more trees may not significantly boost accuracy and will increase training time. It's like adding too many cooks to the kitchen. It might not always lead to a better dish. I'll explain the general behavior of the ExtraTreesClassifier. While it often reduces overfitting, improper hyperparameter tuning can still lead to overfitting even in an ensemble method. It's not a guarantee, but generally true. ExtraTreesClassifier, a type of machine learning model that uses many decision trees to make predictions, reducing the chance of error from a single tree. Extra refers to the extremely randomized way trees are built. N_estimators specifies the number of trees built in the ExtraTreesClassifier model. Max_depth sets the maximum depth of each decision tree in the model. This limits the complexity of each tree. Min_samples_split controls the minimum number of samples, data points, required to split an internal node in the trees. I'm focusing on how we can adjust the settings, hyperparameters, of an ExtraTreesClassifier model to get the best performance. It's like tuning a car engine, you want to find the right balance. This is a multiple-choice quiz testing your understanding of ExtraTreesClassifier hyperparameters. Let's see how well you understand them. Think of max_depth as the height of a decision tree. A tall, complex tree, maxdepth is large, can memorize the training data too well, leading to poor performance on new data, overfitting. By lowering maxdepth, I create a simpler, shorter tree that's less prone to overfitting. It's like simplifying a complex explanation, you'll get a better understanding. This parameter sets the minimum number of data points needed to create a branch in the tree. A high minsamplesssplit makes the tree less likely to branch out wildly and overfit the training data. It's like saying, only branch out if you have enough evidence. This helps create a simpler, more generalized tree. ExtraTreesClassifier uses many decision trees. NESTIMATORS controls how many. More trees usually improve accuracy, but only up to a point. Too many trees can lead to diminishing returns, and you spend more time training with little gain. Think of it like adding more chefs to a kitchen. After a certain point, the extra cooks don't really improve the speed or quality of the dish. While usually true because ExtraTrees uses multiple trees to average out errors, poor settings can still lead to overfitting. It's like having a team of experts. They are generally better than one, but if they all make the same mistake, the team still makes that mistake. This quiz focuses on understanding how changing the settings, hyperparameters, in the ExtraTreesClassifier algorithm affects its performance in a binary classification problem. We'll explore several key hyperparameters and how they relate to model accuracy and overfitting. Get ready to tune those models. The quiz presents a multiple-choice question to assess your understanding of ExtraTreesClassifier hyperparameters. You'll select which statements about those hyperparameters are true. This sets the scene. I'm using a specific machine learning algorithm, ExtraTreesClassifier from the scikit-learn library, to solve a problem where I need to assign data points to one of two categories, binary classification. The question asks which statements about adjusting the settings of the algorithm are correct. This statement claims that increasing the number of trees, n_estimators always leads to better accuracy. I will investigate whether this is always true. This statement says that reducing the maximum depth of each tree can help prevent the model from being too complex and fitting the training data too closely, overfitting. I'll analyze this statement's validity. Here, we look at min_samples_split which determines the minimum number of data points needed to create a new branch in a tree. The statement suggests a higher value results in simpler trees, which helps prevent overfitting. I'll need to determine if that is correct. This statement suggests that using many trees, ExtraTreesClassifier inherently makes overfitting less likely, no matter how you set the hyperparameters. I'll evaluate if this is a generally accurate statement. This row simply indicates that a question is being asked. This row indicates that options A, B, C, and D are provided as possible answers to the question.